Hi, everybody, and welcome to this webinar on artificial intelligence and how it can be used in our work and maybe misused. But more broadly, what are the lessons from AI for this moment in history, for technology, for culture, for the challenges that we face? And I think there are some very important lessons to get our arms around, and that's what I want to talk with you about. But before I get into that, let me just back up a little bit and say, what the heck is AI? You know, we all talk about it, and yet there are very few people who really understand what the technology is. And I think that's necessary if we're going to understand what the dangers are, what the opportunities are, how we can best use AI technology. And that goes for those of us who are using it for design and related tasks. So first of all, let's think about natural intelligence. It's a network of neurons in our brains that we use to model our world, to create a picture of reality. And we use that picture to navigate intelligently, to pick out the things that we need to do or respond to or create and so on. And we do that with language and other things. And similarly, with artificial intelligence, we build neural networks out of computers. So we're just essentially copying a similar kind of network technology. You know, that's what the internet is, right? It's a network or an interconnected web network of data across the World Wide Web. And just in the same way that our language is a network of interconnected words that represent interconnected ideas, that represent interconnected things in the world, so too, we create a picture of the natural world and its interconnections. We gradually learn, evolve, and build up a more reliable networked picture, not only individually, but collectively through our collective knowledge and our traditions and our language and our culture and so on. And through the shared knowledge that we build up over time, represented in something like an encyclopedia, like Wikipedia, for example, a kind of deep network, if you will, of lots and lots of bits of knowledge that are all interrelated with each other that fit into a bigger picture, as it were. And that's all part of an evolutionary network that grows over time, becomes more interrelated and more reconciled, the different parts of it, not perfectly, but mostly reconciled as knowledge and culture and science evolve, and we become a little bit more confident in what we think we know, certainly about nature and maybe about ourselves. And these deep networks are actually all over the place, not only in our human knowledge and understanding, but in the natural world. We now know that the genetic processes are deeply networked processes, that there are all kinds of networks going on in ecologies and in all kinds of systems in the natural world. And of course, our brains are an example of that in many ways. And so in the same way that we are trained on the shared knowledge of a large data set, like what's in an encyclopedia or what's in Wikipedia, we are able to use a resource like that to look up a topic like, say, Stable Diffusion, which is one of the AI image generating softwares. And we can learn about how that works and what all the different facets are and how they interrelate with each other. And in the same way, AI also starts with a process of learning, an iterative process. Basically, what's happening is at each step, the algorithm is checking against itself. The image is getting a little bit more and a little bit more and a little bit more reliable, clearer, less noisy, more like what the prompts are asking for, more like what the data set suggests is the right picture of the world. And in this case, it's literally a picture. It's looking at the entire internet and all of the images that it has in its trove. Then I generated that image on the right, and I said, please draw a clip art picture of a smart woman on a black background, give her the same color of hair and shirt, make her look similar, but with a knowing smile. Now, this is not perfect. It's a little bit like a clever teenager, perhaps, but that's pretty darn good, you have to admit, just from that text prompt to be able to create an image that is that close to what I asked for. And that's what image generating software can do. And that's what AI in general can do. Now, there's a couple of key points to bear in mind. One is this idea that AI can assemble vast hyperlinked web networks, or it can at least crawl through the already assembled vast web networks, in this case, the internet and other data sets that it uses, large language models and so on. And secondly, the ability to let this assemblage evolve and grow more intelligent over time. That, just as Wikipedia is growing and people are adding articles and adding more information and so on, so too AI is growing and becoming more reliable and smarter, if you will, more accurately predicting what the world is going to look like. And sometimes that can be quite astonishing, as we've seen. So when we're thinking about how our ideas work, how we think about the world, they work in networks, right? They work in clusters of nodes of how this idea is related to that idea is related to that idea, in just the same way that the words of my sentence, the sentence I just said, are talking about how things are related to one another, right? So I'm modeling that reality, that networked connectivity. And that's what we do when we are describing something, when we're learning about something, when we're becoming more intelligent. Essentially, we're looking at the vast connectivity of the world, the incredibly deep and rich set of networks that we are only partially understanding at any given moment. And we're building our own little mental model of that is obviously going to be a lot simpler than that vastly complex reality. But there is an important set of correspondences, an important partial symmetry between what we understand and what the reality is. That's why it's intelligent. That's why it's reliable. And that's how our linguistic networks work also. We're building up that picture of the world as we begin to unpack it. Now, two more points about AI that are important to stress here. One is the idea of garbage in, garbage out. So if you have a bunch of junk on the internet, or if you have a prejudiced ideas or misinformation, et cetera, that's going to get in there. And we've seen some of the examples of that in the internet, where it's producing some very troubling outputs as a result of that. And not so much the prejudice and the really disturbing aspects, that's a problem too, but also just the sort of dumbed down groupthink results that aren't really as accurate or as precise as they need to be. And the second point is that networks don't necessarily get smarter. Sometimes they just go off into dead ends and they become very interested in sort of trivial, mundane things that are not really important. They don't have human value attached to them. They become distractions. And we're all familiar with how so much of what we spend time with on our phones is that kind of thing, right? Just the sort of drivel that distracts us and takes us away from other meaningful things we could be doing. So let me just distinguish between two basic ideas here. One is this deeply interconnected network, or what we could call a deep net, and what we might call a shallow net, which doesn't have that interconnectivity that I've described before. And there are lots of examples of this shallow net, or these sort of tangential offshoots that don't go anywhere, so to speak, that are superficial and distracting at best and possibly harmful at worst. And that is where I think a lot of the internet is today. A lot of the fake news and the harm that's happening from social media, all the things that we are all well aware of from the internet. And certainly AI is not going to immediately solve this problem. If anything, it's probably going to pour gasoline on this problem. And the same thing is true for our built environments. The idea that we are fragmenting our built world and we're creating isolated pockets of harm where people are socially isolated, or they're exposed to toxins, or we're not creating these sort of rich, healthy, positive environments for human beings. We're creating narrow little technological solutions, like how to get an automobile from A to B, and that's creating all kinds of other problems that we haven't dealt with. We don't have the externalities reconciled within that larger network. We don't have the feedback mechanisms working in a healthy way. We're just going down one little narrow path into a shallow net, as I'm referring to it. Now, that's sort of the big picture of where I think we are with AI, but what does all this have to do with architecture? Well, quite a lot, as it turns out, and as I'll explain. Let's go back to the early 1960s and the dawn of the computer age, the cybernetic age. Herbert Simon wrote a famous paper called The Architecture of Complexity. He's not talking about literal architecture of buildings. He's talking about the structure of complex systems and the fact that they are, as he described it, nearly decomposable hierarchies. They're sort of central ideas and sub-ideas and sub-sub-ideas and components of things as well. But that near decomposability turns out to be very important. And that's a key issue that was developed later by Christopher Alexander, who was an architect, and many of you are familiar with his work, I think. His first book was Notes on the Synthesis of Form, right around that same time, where he also described the interconnections between things, the overlap, as he referred to it, or the semi-lattice structure of a network or of a design problem. And that, he said, was very, very important. It created these kinds of clusters or diagrams, or later he referred to them as patterns, that were very, very important. It isn't just that there's a network and that there's a lot of connections, but there are certain kinds of connections, rich club networks or little clusters of sub-networks that are very important in the way that they are interconnected with each other and beyond that little node of connectivity. So in Notes on the Synthesis of Form, he asked, what is the relation of the parts of a problem to its whole and to its final form? Is it a pure hierarchy? No, it's not. It's an interconnected web network. Do the parts make the wholes, or do the wholes make the parts? Very important. Do the leaves make the tree? No, actually, a tree makes the leaves, right? So we need to understand this more clearly. How does this work in nature? What do we know about that? And how does it work in human technology? And is that different? Is there something we need to learn from nature about how these processes work? Known as Mariology in philosophy, the relationship between parts and wholes. And this suggests new tools and approaches, including Alexander's pattern language methodology. But before he got into that, he wrote a very famous paper called A City is Not a Tree, where he looked at a very simple problem in the city of Berkeley, and it was a newspaper rack and a crossing light and a drugstore. And he said they are not hierarchical in their relationship. They're more like a sort of rock, paper, scissors relationship, an interactive system. And this is very important, a very important quality in cities. It's not a tree-like relationship. It's a nearly decomposable hierarchy, or it's a semi-lattice, as he referred to it. Unfortunately, we were building tree-like cities around that time, and I would argue we still are. And we need to understand why this is so important, because this tree structure is extremely limited in what it can do, how it can perform. The structure, no piece of any unit is ever connected to other units except through the medium of that unit as a whole. And this is like if we were not free to make friends outside of our family, unless our whole family made friends with the other whole family of that person that we wanted to become friends with. And this is not some simpler, less orderly structure. This is actually a thicker, tougher, more subtle, and more complex view of structure, as he refers to it. So this is his idea. Essentially, a city is not a tree. A design problem is not a tree. It's an interconnected web network with these little clusters that are very important. These diagrams or patterns that form almost like relational nodes in a network, a rich club networks that can be manipulated. And that is exactly the methodology of the patterns. As many of you may know, you can treat these as almost like object-oriented bits of software that can be manipulated and part of a design configuration. They have weak links between the different nodes and then strong links within them. So a pattern is the configuration of real things. This is not just an abstraction. These are real things that happen in space in a similar way. So if you think about a door, for example, probably the simplest kind of pattern you could think of. Well, you got the hinges on one side and you got the knob on the other side, right? And those are the strong forces. They need to be related to each other in a strong force pattern. If you had the hinges and the knob on the same side, you'd have a very unfunctional door, right? You wouldn't be able to open the thing. So that's violating that pattern of strong forces. So the pattern is the pattern of those elements within that larger whole. And in turn, the pattern of the door relates to the pattern of a room, the pattern of the rooms within a building, the building within the city, and so on, and also downscales from the door and the hinges and the screws and the hinges and so on and so forth. And so you can think of it, again, as a nearly decomposable hierarchy, right? The doors, the room, the building as a whole, the city as a whole, and so on. And so this is what a pattern language was this sort of nearly decomposable hierarchy of patterns that described good city form as he saw it. And he provided some evidence for that, of how you can shape things to be most responsive to human need. And you could combine the patterns in a very language-like way, which is what we do intuitively, he thought. But this was a more formal way of doing that, since we've sort of lost that ability. We've lost the unself-conscious way of doing things, as he put it. And this is more like poetry than mere lists, right? It's not just a hierarchical list of items. It's an interconnected web-like structure like poetry. These are real things. They're geometrical. They can be natural or human structures, and they're really made up of patterns, are really made up of other patterns. This is an example from the book. Many of you may be familiar with that. Again, the nearly decomposable hierarchy. The structure of a pattern is very simple and straightforward. The iconic photo behind the title, the upward hyperlinks to other patterns, the problem statement, the analysis, the diagrammatic conclusion, the downward hyperlinks to other patterns that are lower in the rough hierarchical structure, and so on. And this is something that has actually become enormously influential in software and in other fields. The pattern languages of programming, as they're called, or design patterns, are hugely influential. It's become influential in gaming. Wiki and Wikipedia were actually built on patterns. Ward Cunningham, the inventor of Wiki, created it to share design patterns. And he saw Wiki as a kind of pattern language structure, inherently so. And the operating systems, the Mac, other innovations in software, agile methodology, extreme programming, Scrum, and other very influential movements in software, and artificial intelligence, because of course Wikipedia, as one of the largest large language models out there, is one of the resources that artificial intelligence uses as its database, so to speak, to plumb the connectivity of all those structures. So there's literal use of pattern language methodology in that sense, but there's also the larger shared idea of using networks and using these kinds of pattern-like structures in the world of information and in the larger world around us. However, Alexander recognized that there were some remaining problems or shortcomings with a pattern language, not enough ability to customize, because there were only 253 in the original book. It was hard to interface with conventional building systems. And most importantly, there wasn't enough information about form and about geometry. How do you actually shape these places to be good, responsive places for human beings from a human point of view, from a user's point of view, as judged by the users? You know, we don't need to argue about what is good. We can just say, are the users satisfied? Is it what they prefer and what they need? And so the nature of order was really the project that he set about and spent 25 years working on that, looking at how can we operationalize these insights in actually shaping our world, our rooms, our buildings, our cities. How does nature do that? How does nature achieve this fantastic order that we see all around us? First of all, it doesn't make little blueprints. It has something more like a generative process, like codes or recipes for growing form, a little like AI, in fact, in that sense. There's generativity involved, and the results are complex, adaptive, and emergent. And the lessons here are that we can learn from these processes, he argued. We can incorporate them in our technologies. In fact, we've done so in the past, and we still do so now, but in a very sort of limited way, and we can do much better, he thought, especially in our formal systems that have become very brittle and clogged up with these sort of shallow nets that I referred to. And so one of the key insights was that there are structure-preserving transformations when anytime there's a process, like a design process, or you start with something that already exists, whether it's a piece of land or a building that you're remodeling or whatever it is. You start with something that exists, and then you transform it, but you preserve something about the structure. And here's a simple example of that, a famous example from Harold Edgerton, the MIT physicist who did a series of stroboscopic photos. Then he's taking a milk drop here and shattering it against a thin plane of milk. And the result is not a disordered mess. The result is actually more structure, more articulated structure that has very specific characteristics. And this is something that happens in the natural world all the time, known as symmetry breaking. You break the symmetry that exists in the first condition, and yet you end up with more symmetries, more symmetrical structures, new symmetries and new centers with a series of consistent geometric properties. And Alexander was actually able to describe those levels of scale, strong centers, boundaries, alternating repetition, positive space, good shape, and so on. And he was able to come up with a list of about 15 of these properties of good form, as he saw it, or properties of naturally occurring form in the natural world and in buildings and other structures. And they exist throughout human history, not a coincidence, because human beings are generating these properties as they are crafting these places and following these processes and transforming the structures, preserving and extending the wholeness of these structures over time. And you can see lots and lots and lots of examples of this all across human cultures and human history. Maybe not so much in the modern world. That's an interesting point. Maybe our technologies have become a little too brittle, a little too shallow net, so to speak, and we've lost some of this richness that we so desperately need for ecological qualities that we all need in our buildings and in our environments and in our world. And so going back to the neural network idea, we can see this interconnected web network of structures as they transform, as they interact, as they evolve, as they become richer and more articulated over time, in the same way that neural networks do, in the same way that our brains do, in the same way that artificial intelligence does when it is working at its best. Then again, this is something that goes on in the natural world and across many different domains: ecology, biology, physics even, etc. And this is the coded processes that we're now learning so much about in the genetic processes and in the ways that morphogenesis occurs in biological systems, creating this astonishing variety and astonishing beauty across the natural world. And in human traditions, we understand now that these are very similar, these processes that are occurring, or they were up until recently. And this is what generates the richness and the fractal qualities, the geometric qualities that we all love. So here are some of the 15 properties that Alexander identified. I touched on them earlier. I won't spend a lot of time describing these, but you can see that they're very beautiful and very precise geometric characteristics. And they're transformations. They're geometric processes that result from these physical changes, whether it's human beings crafting things or the natural world, symmetry breaking, and so on, evolutionary processes. And for the last part of the talk, I want to show you a couple of AI experiments, and this is using ChatGPT 4.0. There are many other systems out there. ChatGPT is one of the best known, and in fact, you might have seen that they're working now with Apple. So one of the things it's useful for, I think, is just to do preliminary research. Don't take it for gospel, but just start your research using ChatGPT. So you say, what are Chris Alexander's 15 properties and why does he say that they're important? And it gives a pretty good college student level essay kind of answer. Not entirely reliable, not terribly profound, but pretty good, a good starting place, right? And why are they important? What is creating life, wholeness and harmony, human connection, design framework, and so on? Pretty interesting. But then when you ask it to actually draw pictures, it begins to fall apart. And here you see some of this really hallucinating and strange letters. And this is actually garbage, because if you look at other people's drawings or photos, you can see Alexander's photos on the lower right there. So you can see that AI has a long way to go to get to the point of being accurate in describing that. But then, some other sophisticated ideas, like Alexander was trying to use computers to generate more specific complex geometries, harmony-seeking computations, as he referred to them. And ChatGPT knows about that and can tell you a little something about it. And I asked it, well, can you generate harmony-seeking computations? And it gave a sort of college try, right? It wasn't a great example. Here's what it did. The first one, I said, well, you don't really have all of the characteristics there. And then the second one, it tried a little more, but it's still, it's not there, right? So you got to be careful with this stuff. It's very limited in many ways. And yet, again, you can use it to find out what some of the research is. For example, are there aesthetic preferences that most people share? Well, yes, there's a lot of research evidence that shows people's aesthetic preferences, and it'll give you some of those citations, and you can go check them out. People like to live and work in aesthetically pleasing spaces. Integrating aesthetics, biophilia, and traditional architecture into urban design can promote well-being, reduce stress, and improve urban interactions. So again, useful stuff, and I think important stuff in terms of what we're learning through the research, as opposed to what some of our ideologies are about design and what the sort of narrow, shallow net ideas are in some cases. What are the aesthetic or geometric properties that are preferred by most people? Well, it can begin to tell you what some of those are. Again, don't take this as gospel, but it is an interesting first step in understanding some of these characteristics. And I think some of them are pretty well confirmed by the research. And, cultural and contextual considerations, got to understand that. There are socially constructed aspects of what people like and prefer, but there are also natural preferences, biological preferences based on our evolutionary history. And they mentioned some of the studies and theory supporting these preferences: prospect refuge theory, attention restoration theory, and what do you know, pattern language by Christopher Alexander. Some of his ideas are being brought up by ChatGPT there. Now, if you say, well, can you draw a beautiful building as judged by most people and their natural aesthetic preferences? Okay, so this has certainly some traditional qualities. It has biophilia, it has water, it has symmetry and proportionality and some other things. But I think you could critique it and you could say this is a little overwrought. It's a bit hallucinatory, perhaps, which is what happens with generative AI sometimes, and a little bit weird in some aspects, a little bit like a dream, like a hallucination. But nonetheless, there are some interesting characteristics there that it gives you some ideas about that. Here's another one. I just asked it the same thing again, and it gave me a more classical building, this time with a pediment and some columns. Again, a little overwrought, a little out of proportion and cartoonish and a bit garish even, but again, it does evoke some of the characteristics that we know from the research people do prefer in their aesthetic environments. Now, I want to end with a couple of conclusions, and one of them is simply to be careful to avoid these shallow nets, the superficial titillation, the pseudo-intellectual nonsense, the image-based noise, banality, and clutter that the internet is full of, and that our culture, frankly, is full of, and that I think is poisoning us in many ways and destroying our environment, destroying our sustainability of our world in many ways. And that goes for the sort of wacky, wild Kool-Aid style stuff, the sort of edgy, neo-modernist stuff, and for some of the sort of, you might say, over-the-top McMansion style buildings, right? Just let's throw another gable on, let's push and pull. I think we've got to be careful with all of that. And certainly with generative AI, we can go wrong in a lot of different ways here. I think instead we need to draw on the deep nets of human nature and culture. We need to curate the results carefully, use it as research, but only to enrich this human process. And here's a generative AI drawing that I think is actually pretty darn good. I used it to draw an urban environment that had walkable mixed use and some characteristics of sustainability in terms of the urban form and the walkability and the multimodal transportation. And I think also the aesthetics are quite complementary to what most people find desirable, the biophilic characteristics and the natural grouping and symmetries and chunking and so on and so forth. So I think there's a lot to learn from AI, not only to learn from using the technology, but to learn from the wider lessons about the technology, what it reveals to us about this moment in history and its dangers, not only about AI, but about the internet and about social media and about all the technologies that we're using right now, how we can steer those into the directions that we need to truly address our challenges and not to neglect those challenges and be overwhelmed by them, or worse, to create an even more dystopian world with these technologies. To be clear, I think there are great promises in the artificial intelligence technology. This is a natural evolution, I think, of human intelligence into new modes. We started with language, we began writing, and I think this is a natural evolution in many ways, but it has to be curated, it has to be managed, it has to be steered for human ends and not for the sake of the technology itself. That's a theme that runs throughout human history. getting ourselves in trouble as a result of our technologies. And we really have no choice but to confront our own responsibility in using these technologies and to steer them in a more hopeful direction.